Hello again. So now we're going to graph this example of an absolute value function or absolute value equation. Okay. So as before, for an absolute value function like this, the domain is immediate. It's negative infinity to infinity. In other words, all the real numbers. Okay. Also, as we've already seen, the range, we're going to get that once we've determined what the corner point is. Okay. And we want to recall, so therefore the first thing we're going to do is we're going to find the corner point. And remember that the way we're going to find the corner point is we're going to first find the x coordinate of the corner point by setting the inside of this equal to 0. Let's do that together. So for example, here, in order to find the x coordinate of the corner point, set the inside of the absolute value term equal to 0. So here I'm going to set this equal to 0. So now I'm going to solve this for x. So minus 3, I get x, because the plus 3 and the minus 3 go away, equals, what's 0 minus 3? That's negative 3. So that's the x coordinate of my corner point. Right? And now what I'm going to do is I'm going to find my y coordinate. Now how do I find the associated y coordinate? I'm going to use this x value in the equation. So my associated y value is going to be y equals 1/3 times the absolute value of negative 3 plus 3 minus 3. Now negative 3 plus 3 is 0. So this will be 1/3 times the absolute value of 0 minus 3. What is the absolute value of 0? 0. 0 times 1/3, that's 0. So this will be 0 minus 3, or in other words, negative 3. Okay? So now I have my corner point. Okay? And let me get rid of this so we can continue working on this problem. Stand by, please. Okay. So now we want to know, does the absolute value function in this case open up like this, or does it open down? We can see here that the coefficient of the absolute value term is actually positive 1/3. So it opens up. Okay? That means that this y value at the corner point, the y value, will be the minimum. So the range cannot be determined. It will go from negative 3 to infinity. If this 1/3 had been negative, that would have indicated it opens down. That would have turned this y value into a maximum, and the range would have been from negative infinity, comma, to negative 3, and the close bracket on the negative 3 side. We now want to calculate the x intercepts, okay? Now, in order to solve for the x intercepts, to find them, we're going to set y equal to 0 and solve for x. Okay? So in other words, I'm going to set this expression equal to 0. Let's do that together here. 1/3 absolute value of x plus 3 minus 3 equals 0. Now, the first thing I'm going to do is I'm going to get the absolute value term by itself. So I'm going to have to add 3 to both sides, okay? Plus 3 plus 3. Okay? So I get 1/3 x plus 3 equals positive 3. Okay? Is the absolute value term by itself yet? No. It's being multiplied by 1/3. Okay? So what I can do is I can divide both sides by 1/3. Okay? Okay? So on this side, I'm left with just the absolute value of x plus 3. But now we ask the question, what is 3 divided by 1/3? Okay, that's an important question. And so here, whenever we divide by a fraction, we multiply by the reciprocal. Here I'm dividing by the fraction 1/3. So this right-hand side, I can write it as 3 times, what's the reciprocal of 1/3? 3 over 1. Do I know how to multiply this whole number times this fraction? I don't. But I know how to rewrite this whole number as a fraction by setting it as the numerator and 1 as the denominator. Okay? So this is 3 over 1 times 3 over 1. In other words, this became this 3 over 1. This 3 over 1 came from this step here. And then now, do we know how to multiply two fractions? Yes. The product of two fractions is the fraction whose numerator is the product of the numerators of the fractions being multiplied and whose denominator is the product of the denominators of the fractions being multiplied. In other words, to put it simply, I just multiply the numerators. So 3 times 3 is 9. And I multiply the denominators. 1 times 1 is 1. And then, whenever I have a fraction whose denominator is 1, that fraction is equal to the numerator, in this case 9. So in other words, now I see that this x plus 3 equals 9. Aha! This is an absolute value equation, right? So now, there's two possibilities. Either the x plus 3 is in fact positive, in which case, how does it come out of the absolute value? Directly. Unchanged. So in other words, either x plus 3 is already positive, in which case it must equal 9, or x plus 3 is negative, in which case the opposite of the inside must equal 9. Right? So this side comes from the assumption that the inside is positive. If the inside is positive, it just comes directly out of the absolute value. On the other hand, if the inside is negative, it comes out of the absolute value when we take its opposite by multiplying by -1 on the outside. So now on this side we have, okay, minus 3, we get x equals to 6, okay? What about the other side? Well, I'm going to divide both sides by -1, and I get x plus 3 equals -9, okay? Then I subtract 3 to the other side, minus 3, and I get x equals -12, okay? I now have my two solutions. Let's test them. 6 plus 3, that's 9, the absolute value of 9, so that one works. What about -12? -12 plus 3, that's -9. The absolute value of -9, positive 9. So we see that these are indeed our x values. And these solve this equation, which means that they correspond to our x-intercepts. Our x-intercepts are therefore 6, 0, and -12, 0. Okay? And now finally, we will be able to find the y-intercept and then plot the graph. So I want you to recall that to find the y-intercept, we set x equal to 0 and we solve for y. Okay? So let's look at this expression. Y is equal to 1/3 absolute value. I'm setting the x equals to 0. So 0 plus 3 minus 3. Okay? I'm now going to calculate what this simplifies to. This is equal to 1/3 times. What's 0 plus 3? That's 3. So this will be the absolute value of 3. And then minus 3. What is the absolute value of 3? It's just 3. So this is 1/3 times the number 3 minus 3. Now, I'm going to calculate this on the side over here, okay? What is 1/3 times 3? The first thing I'm going to do is I'm going to rewrite this as a fraction. It can be rewritten as 3 over 1. So this is equal to 1/3 times 3 over 1. Okay? And now, how do we multiply fractions? We multiply fractions across, right? So in other words, the product of these two fractions will be the fraction whose numerator is the product of the numerators of the fractions being multiplied, and whose denominator is the product of the denominators of the fractions being multiplied. So what is 1 times 3? 3. And what is 3 times 1? 3. And what is a fraction whose numerator and denominator are equal? Just 1. Right? So I can rewrite this expression as 1 minus 3. Now what is 1 minus 3? 1 minus 3 is negative 2. Okay? So I now have my y-intercept. It's going to cross the y-axis at negative 2. And so that corresponds to the point 0, comma, negative 2. Okay? Okay. Now, let us make a small table here and graph this function. Okay? It's a beautiful thing. Okay. So as before, one of the things that I like to do whenever I'm doing a graph like this is I like to put my corner point in the middle, and I like to go 2 to the left and 2 to the right to make my x values that are going to be nice for us to graph. Okay? So let's call this x, let's call this y. I'm going to put my middle one, negative 3, right? And, okay. So 2 to the left would be like negative 2, negative 1. Well, that would be 2 to the right. And then 2 to the left would be like negative 4 and negative 5. Now I would plug these values into this expression to get the associated y values. Now here, okay. What do I want to say? Okay. So what I want to say is I could actually perform the calculations with this table. But if you notice, there's a 1/3 in front, you see? So I don't want to multiply 1/3 times just any number, because the numbers can get complicated, right? If it was up to me, I would want to make this absolute value term come out as multiples of 3, so that I'll get like whole numbers to plot with. Obviously, here this is something that's, I don't want to say it's artificial, because it's kind of artificial. You know, in real life, the problems are gonna have numbers that are slightly, well, maybe not slightly, but that might be ugly numbers, you know, and that's why we use calculators. But when we're doing textbook type problems like this, you know, having this kind of like thinking carefully about how you can graph it is good. Okay, so even though, yes, here, you know, I have 1/3, and I can try and think, okay, I'm going to try to make this multiples of 3 so that it'll be easy to carry out this multiplication, that kind of thing. It's still valuable. But, okay, so having said that, we're going to fill out this table, and then I'll show you how you could do what I was suggesting earlier to get a nicer table, and then we'll plot the graph, okay? I want you to see both, so that on the one hand we can work with fractions to develop some practice to remember some things, and then also to show you how you can do these problems a little bit more easily sometimes when you just want to get a graph to get some idea, okay? So I'm going to calculate what the y value is for -1. Let me do that here. So for x equals -1, my y will equal 1/3, right? Right, from here, times the absolute value of -1 in the place of the x, because I'm using -1 here, plus 3 minus 3. Okay. Now, notice here, what is -1 plus 3? That's positive 2. Okay. So this will be the 1/3 times the absolute value of 2 minus 3. Now, what is the absolute value of 2? The absolute value of 2 is 2. Okay. So this is the same thing as 1/3 times 2 minus 3. How can we write 2 as a fraction? By setting it as the numerator and 1 as the denominator. So that is going to be 1/3 times 2 over 1 minus 3. Notice how at each point I'm keeping the calculation together so I don't forget a step somewhere else. How do I multiply these fractions? I multiply them across. 1 times 2 is 2. 3 times 1 is 3. And then minus 3. Aha! Can I perform this subtraction? I can't. Because you see, this 3 is not a fraction. So that's the first thing we have to do. We have to make it a fraction. So that's going to be 2/3 minus 3 over 1. Notice how I made it into a fraction by setting it as the numerator and 1 as the denominator. Now, I need to make this I need to make it a fraction equivalent to 3 over 1 that has the same denominator as this fraction. The advantage is that because 1 is the denominator of this fraction on the right hand side of this expression of this subtraction, I merely have to find what number multiplies to give me 3, what number multiplies 1 to give me 3, and I multiply that number times the bottom and the top. Okay, and what is that number? It's just 3. Okay, because when I carry out this multiplication here, I'm going to get a fraction equivalent to 3, but it has the denominator 3, which will permit us to actually perform the subtraction. Okay, so you can see that this will become 2 over 3 minus 9 over 3. Okay, now look at this. Since these fractions have the same denominator, I can perform the subtraction by subtracting the numerators and keeping the denominator. What is 2 minus 9? That's negative 7. And the denominator is 3. So you see here the value is negative 7/3. Okay? Now, so one of the reasons why I was suggesting earlier to pick nice x values by trying to find numbers that'll make this into a multiple of 3, right? It's for exactly this kind of reason. Now this is not bad, okay? And I'm gonna fill out the rest of this table so we can again review calculations of fractions, okay? But then I am gonna show you how you can find the nice x values so we can also avoid that. You know, all depending on the situation, okay? So let's continue here with the next x value. And also the other reason why I mentioned that is because I want you to realize that there's no right x values to use for your table, unless we're dealing with a particular physical problem that you want to look at the function near that region for whatever your problem is focused on, right? Then you will plot those x values. But in terms of drawing the textbook graph, you know, what x values you pick is not really that significant. You know, obviously in my case, I'm trying to draw the textbook graph that emphasizes where the corner is and that kind of thing. Also, strictly speaking, I don't have to plot this one because I know this is going to be 1/2 of the absolute value, right? It's two lines that are like this, right? So I've already gotten the vertex, which is this one. I have a point over here. I have a point over here, so I already have this side taken care of. I just have to calculate a point here to get this side, okay? Strictly speaking, if I wanted to think of it that way. But I don't want to think about it that way, and also this is going to give us an opportunity to continue practicing. Because, of course, one of the things I want you guys to observe is that some of the problems I'm going to do, you don't have to deal with fractions at all, and some of them we do. And I need to make sure that happens because I need to make sure that you guys don't lose the ability to calculate with fractions. And if you have questions, I want you to see me calculating with fractions so that your questions are resolved little by little in your brains. Yes? Okay, good. Let's go with x equals negative 2. Ah, yeah. Yeah, for x equals negative 2. Watch. So now, okay. So I'm going to plug in here. Y is going to equal 1/3 negative 2. I'm replacing the x with negative 2, right? Plus 3 minus 3. So now here, what I have to do is I have to ask, what is negative 2 plus 3? Negative 2 plus 3 is positive 1. So I'm going to get y is equal to 1/3 times the absolute value of 1 minus 3. What is the absolute value of 1? It's just 1. So this becomes 1/3 times 1 minus 3. Now, we know that any number times 1 is just the same number, so we don't even have to do the conversion to a fraction and all that rigmarole here. All we have to do here is just realize that this is going to be 1/3 minus 3. So now we have to do a little bit of work here, okay? We have to figure out what is this subtraction, okay? So this subtraction can be written as 1/3 minus 3 over 1. Notice I changed this number 3 into a fraction by setting it as the numerator and 1 as the denominator. Now, in order to effectuate the subtraction, I have to put them on a common denominator. So I'm going to have to multiply this fraction. I'm going to have to multiply this fraction by another fraction with the same numerator and denominator, but with an I to make this product on the bottom equal to 3, so that these two fractions will have a common denominator and thereby permit us to perform the subtraction. What times 1 gives me 3? 3. So I'm going to multiply the top and bottom by 3. Okay? So now, this is going to be 1/3 minus, what's 3 times 3? That's 9. What's 1 times 3? 3. Aha. And look, let me point out something else here. Notice, what is 9 divided by 3? 9 divided by 3 is 3. Right? So that means that you can see this expression here, 1/3 minus 3, is exactly the same as this expression. This is 1/3 minus 3. But this expression is more valuable to us in this context because we can actually do the subtraction, which is what we need to do here. So what is 1 minus 9? That's negative 8 and over 3. Okay? So this is negative 8 over 3. Okay? Okay. And let us now proceed to continue filling this table. Okay? What about for x equals negative 4? For x equals negative 4, okay, I'm going to do the same thing. Y is equal to 1/3 times the absolute value of negative 4 plus 3 minus 3. Okay. So, this is the same thing as 1/3 times what? What is negative 4 plus 3? Aha, it's negative 1. And then minus 3. What is the absolute value of negative 1? It's positive 1, right? So I can replace this as 1/3 times 1 minus 3. Wait a minute, doesn't this look familiar? This is interesting. Aha, I know what it is. It must be negative 8/3. How do I know that? Because this is just the calculation we just did. Okay? Moreover, it follows because of the symmetry of the absolute value about the corner point. The vertical line that goes through the corner point of the absolute value is a line of symmetry for the function. So therefore, since this is 1 to one side and this is 1 to the other side, the y values will be the same. I mean 1 to one side of the vertex, 1 to the other side of the vertex. Similarly, this is 2 away from the vertex. So therefore, the negative 5 being 2 away from the vertex, the y value must be the same as well. So this is going to be negative 7/3. Okay? So by using the symmetry, we were able to avoid a lot of the calculation. Okay? Now very briefly, look, if we just wanted to graph it, we could just graph these points and be done with it. But I do want to take a moment to walk you through what I was saying earlier about how do we find like nice points, okay? So we knew that negative 3 made the inside of this 0, right? That's how we select the location of the corner point. But now I want to make the table a little bit bigger for the purposes of like having more nice points to plot. Aha! What if I make the inside equal to 3? Because if I have 3 here, 3 times 1/3 will be 1. You see, if I had the inside of this equal to 6, then 6 times 1/3 would be 2. If I had the inside of this equal to 9, then it would be 9 times 1/3, which would be 3, and so on. Right? So, I'm just going to make 2 points, okay? So, what I want to do now is, I'm going to make this x plus 3 equal to, let's say, 3, okay? What does x have to be? Aha! Minus 3, x equals 0, right? So if I were to set x equal to 0, then what will my y be? Well, 0 plus 3 is 3. 3 times 1/3 is 1. 1 minus 3 is -2. And so we can see that I guess even though it's out of order, let me put that value over here. So it would be 0, -2, okay? And in fact, we can see that that's completely consistent with this point here, okay? In fact, let me do this a little bit more carefully, just so that you can see this more clearly, right? And so that you can get a better idea. Okay. So what I could do is I could set this absolute value of x plus 3 equal to 3, as we just did. There's two possibilities. Either the inside is positive already, in which case it comes out as x plus 3 equals 3. Or the inside is negative, in which case, how do we pull it out? As the opposite. Right? This one, we already solved it. That gives us the case x equals 0, y equals -2. Y equals -2 when we plug it in, right? What about this side? Well, I can see this as x plus 3 equals -3 because I divided both sides by -1. Then if I subtract 3 here, I get x equals to -6. Let me put that in here, -6. Now, that value of x has been chosen to make this absolute value of x plus 3 equal to 3. So this will be 3. 3 times 1/3 is 1. 1 minus 3 is also -2. Okay? And so that's just to give you a flavor of how we can pick points for this graph. Now, I'm not going to wait any longer, and we're going to do the graph of this before this video becomes unbearably long. Okay? Now, of course, I do want to point out that if you had wanted to, you could have done the absolute value of x plus 3 equals 6. That would have given you two values. The absolute value of x plus 3 gives you 9. That would have given you two values. Those would have been very nice x values to get the y's for the graph and so on. Okay. Wait a minute. I'm not even thinking yet. Okay, now before we draw the xy axis, what we need to do is we need to figure out where we want to focus our xy axis. In this case, you can see that I have negative values largely for my x. So I don't have to draw the first quadrant, right? And my y's are mostly negative, so I don't have to draw the second quadrant. I can draw basically the third quadrant roughly, and it'll give us what we need. Right? And let's think about what we have to draw here. I'm just going to plot this one, and this one to make it easy for us, okay? Or maybe not. Let me see. 1, 2, 3, 4, 5. So 1, 2, 3. Wait, no. 3, 4, 5. Okay? -1, -2, -3, -4, -5. Okay? By the way, notice how I'm putting the numbers above the x-axis. Since I know the graph is going to be in this region, that'll help us to avoid clouding up the graph paper here. I need -2 and these values. So now watch this. -1, -2, -3. Now watch. I can easily slice this into thirds. You see? So I can even plot it very carefully. And then, do I have everything I need? I have everything I need now. Isn't this amazing? Okay, so watch. Okay, so here we go. Wait, what's happening here? So at 0, it's -2. So that'll be right here. Okay. At -6, it's -2. So I can make this a little bit longer. Okay. So let me go down here like this. I'm hoping this is roughly horizontal. Okay. At -1, it's -7/3. Notice I've sliced each of these into thirds. You see? So if at -1 it's -7/3, it's going to be 1, 2, 3, 4, 5, 6, 7. It's going to be right here. Okay? -1, and it's at 7/3. Okay? And that's also the case at -5. So at -5, it's at -7/3. So it's going to be, like about right there. At -3, it's going to be -3. So it's going to be like right there. At -4, it's -8/3. So that's about right here. And the same thing with -2. By 8/3, I mean this line, right? Because if you notice, 0, 1/3, well, -1/3, -2/3, -3/3, -4/3, -5/3, -6/3, -7/3, -8/3. You see? So that's how you can graph this. Oh my God, that's awful. Okay. You can tell why I didn't go to art school. You know, this is like, it's horrifying. No, but anyway, this is our graph. These are the points that led to the graph. Okay. One of the other things I want you to observe about this is as follows. Notice this coefficient of the 1/3. This, if we were thinking about lines, a line with 1/3 would be a shallow line. Well, it wouldn't look like this. It would have a positive slope. It would look like this, a line with 1/3, right? But it would be very shallow in angle, because for 3 to the right, it would go up 1. And we can see that kind of explains why this graph is kind of like very shallow in its tilt. Okay. We will also see later that this 1/3 corresponds to what is known as a vertical shrink. And so what you can think is that this graph, what would have been the absolute value graph that goes up like this, has been squashed. Okay. But we're going to get into those details later. But here's the graph. I hope you have enjoyed this, and I'll see you again soon. Thank you.